Okay, so here we have finished the radio. I have cleaned the cabinet. I haven't done any polishing on it or anything else. I just cleaned the knobs, put it all back together, and it turns out that this radio, it's very beautiful. So I really like it. I'm anxious to have it working on a bench somewhere or in my office, or I don't know, I will find a place for it. What have we done so far? So we have done in the previous part the electrical restoration, and in this part it will be very short. We will test one more time the radio back in its cabinet with the Pardot mini whip antenna, which by the way is a fantastic antenna. I'm really sorry that in the original building and testing the Pardot mini whip antenna, I have not grounded this antenna properly. So right now we are grounded and everything works fine. I'm sorry for that part. For whomever got to see it, I have cut it out of that video. It's not relevant, so I will make this the official testing of the antenna video as well. So back to our little Tesla. As you can see from the front side, it looks pretty cool. The radio is now working. Let me give it some volume. Let's see what we can find.
Perioada 2015-2017 a fost comandantul forței expediționare Antarctica. Terminăm în 2013, plecăm fiecare în locul de baștină și ne continuăm activitatea de ținem legătura
Here is the power supply for the antenna. So when we kill it, the volume goes pretty down. But when you have it activated, everything is perfect. Let's see what else we can find. The radio could use some front end amplifier for the antenna, but that was not the purpose of this radio. This was built as a small little radio. Let's see on long, let's go to shortwave. Let's see on shortwave what we can find.
But that does not necessarily mean I'm going to die. I know I'm going to die tomorrow. God forbid. I want to live until I'm...
We are still not in the night, it's only early evening, so propagation is not very good right now.
friends, amongst peers, etc., etc.
Okay, so you got the idea. So the radio, it's working. Now, what else have I done? Let me show you in the front right here. I have made some screws for these knobs. You know, I was getting worried with the way the previous techs dealt with the screws, but I have made this these screws from a long, let's say, threaded bar. I don't know where I got it from, but come on, he's not cooperating. It's a long screw. So as you can see, what I did, I just cut 1.5 centimeter long threaded bar, and I have made with the Dremel slot for the screwdriver in the head. So that's it. And this screw, let me see if I can show you. Come on. Okay, so this screw, as you can see, goes through here and it stops somewhere in the bottom. It goes right through the shaft, and it's pretty deep in there, so there is no worry whatsoever for electrocuting ourselves from now on. It goes right in there. So this is the back side. As you can see, I have a replacement panel. I got it from somebody who's doing this reproduction back panels and dial lights and knobs, and also this power cord. It's from him as well. It was sent to me as a bonus because he's a really nice guy. I also did something for him, and he to thank me, he sent me this power cable as a bonus. But we now have a brand new back panel. I have found some replacement screws for this radio, so now we have all the screws populated everywhere. Okay, so if we take the back panel off, let's see. In the future, I'm very curious how well this will behave, but it seems to be from the same material. The only difference is that I don't have the serial number punched right down here, but the rest is pretty incredible. Now let me take the chassis out, and I will show you what I have done on the inside. Okay, so now that we have the chassis out, I want to show you what I did on the inside. I have replaced the grill cloth with brand new material, and I also replaced this they were felt pads. These ones, I have replaced these ones with some foam. This is the type of foam that is used to stick on the side of the doors so that the doors close pretty well, airtight, let's say. I have replaced also these screws, and I also replaced these screws, and I cleaned up a little bit this plate. This here are some material type like a crushed shoelace, let's say. They have some slots here, and these were in perfect condition. I just took some super glue, cleaned the place, and reattached them right here so that the dial plate does not hit the bakelite. Okay, so there is one more thing I would like to say, is that the dial pointer, it has been painted with whiteout, and I think it looks pretty cool. It stands out pretty well. Okay, now that we are all back together, let's turn on this radio. It takes some time till it warms up. This is the magic of tube radios. Let's see. I have given it a little bit of volume. Okay, now have some action. Let's try medium wave. Only music. I don't want to hit any copyright. Yeah, so unfortunately, because of all this copyright things, we cannot listen to it any longer, but it works pretty well. It's not a very sensitive radio, and in the end it's not the best performer I have ever seen, but it's a cute little radio. It surely works as an kitchen radio, let's say. Let's see and try to measure the temperature that the wire wound resistor that we restored it's getting at with the radio inside the chassis and with the all brand new tubes with the back panel on, and let's see what we get. I will measure it for some time and monitor it, and when we will settle I will be right back. Okay, so let's measure the temperature right here. I will insert the temperature probe right in this slot here, and we will measure the temperature at this metal bracket. Okay, so here we are set up. I have installed the temperature probe. We are reading the temperature in degrees C. Let's turn on the radio. Put it on medium volume. Let's hope there is nothing tuned, and we shall see how the temperature it's gonna rise and where it's gonna settle. So as you can see, we are still climbing, steady state. I just wanna say a few things about working on this type of radio. It was fun. I really liked the construction. I really liked the idea of flying leads and have little pigtails where every component has its leads put through and soldered together, and all this type of construction. It's pretty interesting. It's not fun in the sense that it's not easy to work with it. If you want to make everything look decent, I tried not to cut the leads and solder them together for the new components. I tried to and succeeded in removing all of the old leads out and all the capacitors out, and I have cleanly installed with fresh solder all of the components. So it's time consuming, but it sure looks nice at the end. The cabinet should be pretty easy to polish, to remove the lacquer and to polish. You can find this gorgeous replacement back panel on the link on the screen. I also when I ordered this, the website did not had any option to order the back panel. I just found it on the website and I have written the email. You can also see the email on the screen. The gentleman replied very fast. It was very nice to communicate with, and everything arrived well packed and safe and really quickly. So that was a very helpful thing, because I really did not like the back panel. He also has a lot more stuff for a lot more radios. It's just a hobby for him, but he does pretty nice things. So please feel free to contact him and to buy anything you need from his store. Okay, so we are about, let's say, 10 minutes later, and the temperature, it's around 132 degrees C, and I think we can safely say that at this temperature the solder will not melt, so we will have no problem whatsoever with the resistor in the future. Let's see, the top of the radio, it's pretty hot. I can keep my hand on it, but on this end where the resistor and the power tubes are, it's pretty hot. On this side it's mildly warm, but here it's cooking. So as you can imagine, this radio gets quite hot. So it might be nice not to have any kids or pets or anything around it, but in a safe environment it's pretty safe. One more thing, this radio is very dangerous to work on. If you don't have an isolation transformer, you really should not be working with this type of radios, tube gear in general. There is high voltage inside of these radios and it's pretty dangerous. So please be careful. If you're following along, you are doing so at your own risk. You have been warned. Okay, so just for fun, I have just inserted the tip of the probe on this upper side of the chassis, and as you can see there are 60 degrees inside of this radio, and I assume that this temperature will go up. Okay, so just for fun, let's try the other side of the chassis. Okay, so as you can imagine, and as I said, in the left side of this radio things are gonna be much cooler. This surely seems like it. There are maybe 20 degrees C difference between the two parts of the radio. Okay, so these are all of the components that we have replaced inside the radio. There are only capacitors, the little resistor that we had previously been installed instead of the wire wound resistor. We have the grommets for the trimmer cap, some wires, the grill cloth, which as you can see it looks pretty darn awful. I did not try to clean it. One reason that determined me to change it was that it was coming unglued from the plate. So yeah, this is it. We have the spacers or the foam, I think it's foam or felt, I have not decided yet, for the speaker protection. We also have this light bulb that it's bad. So this is the Mr. Carson's lab capacitor tester. We will be testing it to try and see if how bad these caps are leaking, and it's a very nice device because it does not use high voltage, so it's much safer. We have here these two caps. These are brand new caps, the types that I have used inside the radio. This is a 0.01 microfarad and this is a 0.1. Yeah, so a 0.1 and the 0.01. So we will use them to compare with the caps from this radio. Let's hook this one up. Okay, let's turn the device on. So the idea is that we need a green light. So if we go into the electrolytic capacitor position, you can see it does absolutely zero because it's charging so fast. So now if we test it, it goes up and down that fast. So this is the behavior that we want. And also we have one more position here, the forecast position. It's a the most sensitive position for this device. So if we click into forecast, things should really stay the same as a green light. So we know that this cap, it's pretty good and it's not gonna fail in the future. These caps have really low leakage. So back to the polypropylene, we hit discharge, yeah, and now let's try and see. Okay, let's try with one of the caps from the radio. This is a 0.01 microfarad. So let's see what happens. I will clip it in. Okay, so we have it clipped in. We're on discharge position. Let's see what happens if we hit test. So you remember how fast the good cap, this cap came down. So this is clearly not gonna come down anytime soon. This tester is using right now 27 volts to test this cap, and even at 27 volts this cap, it's bad, and it is rated for 400 volts. So yeah, these 0.01 caps are the ones that are used as coupling caps inside this radio. So in the polypropylene position, it's not coming down. Let's discharge it first. It's a good practice. Okay, so we have the cap discharged. This one is also a 0.01 microfarad and it's a 600 volt cap. So as you can see, it's starting opening and splitting from one side. So let's see what's happening. If we clip it in, let's hit test. I'm not expecting this one to come down either, and it is not, so it's staying on maximum scale. Let's try it in the electrolytic position, it goes down. So it does have leakage. Good. Let's see some other cap now. For example, this one is a 5000 picofarad. This one is a 1000 picofarad. .500 picofarad. This one is a 0.064. So let's see this one, for example, just to see what happens. So if we hit test, this should in theory take much longer, but if we switch to electrolytic position, we see now the cap is charged, but when we go to the polypropylene position, it's not coming down at all, even if this cap has reached the 27 volt mark. So this cap is bad. Discharge it. This one is a 0.1 cap, so let's see how this behaves. This one is the precision one, which measured 30% above. So if we hit test, it's gonna start charging, and this should take a little bit of time, but not too much. Let's try it on the electrolytic. Now the cap is charged, and if we hit poly, it's not coming down. So it's definitely leaking badly. For comparison, let's discharge this cap. Okay, so for comparison, let's try a good brand new 0.1 cap that we have. Okay, so this is the cap that we have. Replace the ones inside. Let's leave it on the polypropylene position and let's hit test. Let's see how fast this guy comes down. It should reach its capacity and come down. It's taking its sweet time, and it started to come down, and as you can see, we are reaching green light, no problem whatsoever. If we switch to forecast position, which is much more sensitive, we have no change whatsoever. So this cap is good. Let's discharge it, and just for fun, let's see if we put it in the electrolytic position. We hit test, it goes pretty much all the way down, and if we switch it to polypropylene position, nothing changes. So this is how a good cap should behave. Even if we put it in a forecast position, nothing. So this cap has no leakage whatsoever. Let's discharge it. This one, it's also a 0.01 cap. Yeah, so let's see this one, how good it is. Yeah, if we hit test, we're in the forecast position, so yep, poly, nothing. If we hit electrolytic, it's charged, and if we hit it right back to poly, it goes right back up. So this cap is also bad. So as you can see, all the caps in this radio are badly leaking and needed to be changed. Just for fun, let's test this big one. This is a 0.64 microfarad. This is the biggest paper cap that we had inside this radio. Let's see how this one behaves. Let's put it into electrolytic. Let's hit test, and it's charged. And if we switch to poly, it goes right back up, and it's not coming down anytime soon. So this big guy, it's also faulty. All the caps in this radio needed to be changed. If we hit discharge, we are discharged. Let's see for fun this replacement cap. This was instead from the plate to the cathode of the rectifier tube. This is definitely a replacement cap inside of this radio. Let's see how is this guy doing. This is a Russian cap, plus minus 10%. So we are in the polypropylene position. This is a 4.7 nanofarad. It's pretty small, so it should come back down pretty fast, and we are not coming down. If we hit electrolytic position and then in polypropylene, it goes right back up. So even if this is a replacement, it's still a paper cap and it's still bad. And the last one, it's another 0.1 cap. Let's see how this guy does, just because we've tested the others. Let's hit test. We're not expecting to come down in the polypropylene position, so go to electrolytic, and then in polypropylene position, it's not coming down. So this one is also bad. So all caps needed replacement. We replaced everything. We replaced the tubes. We now have brand new tubes and all of these guys. And this is what I was saying, it's pretty nice because this outside shell, it's rigid. I don't know the material that it is made out of, but you can burn the wax out and take the wax out and restuff them, and they would look pretty nice inside of this radio. So for part 3, if I ever decide to make one, we will try and do something about the second IF transformer, because during the alignment the slugs or the tuning slugs inside of the coils have bottomed out. So we can try and find out what the capacitors are inside of the IF transformer, and if needed we can increase or decrease, or depending on what we need to do, find out what appropriate value for a new capacitor we need in order to have the slugs at maximum amplitude be in the middle or somewhere around the middle of the tuning range. So yeah, thank you and see you guys soon.